Hello, continuing with a little bit of geometry. This lesson will go over section 9.5, which is on page 502 in your book, the distance and the midpoint formulas. Okay, let me show you a little bit about the distance formula. If we wanted to find the distance between point P1 and point P sub 2, so point 1 and point 2, how would we do this? Pretend that these two lines aren't here right now. Well, every point has a coordinate. So point 1 has the coordinate x sub 1, y sub 1. That just indicates the xy coordinates of any point. And point 2 is x sub 2, y sub 2. So what is the distance from these 2 points? Well, we can use the Pythagorean theorem. We can say, well, this distance looks like the hypotenuse of a right triangle that we've drawn right here. And we know that the legs are the A and the B, and the hypotenuse is the C, and A squared plus B squared is equal to C squared, correct? So we have A squared plus B squared is equal to C squared. If we wanted to solve this equation for C, if we have something squared, what we can do is we can square root both sides. Then, not to confuse you, hopefully I'm going to switch these around. So we would have C is equal to the square root of A squared plus B squared. And this basically is the distance formula. Well, what is A? A, if we called this side A, we would find the length A by finding the difference between the y coordinates. If this was, for instance, like a y of 5, and this was a y of 1, 5 minus 1, this would give us a distance of 4, right? So we know that the distance is going to equal the square root of one side squared. So that would be, if we chose this to be A, this would be y sub 1 minus y sub 2. Notice it's A squared, so we'd have to square it, plus the other side squared. Well, the length of this side is the difference of the x coordinates. Here we would take x sub 2 and subtract x sub 1. X sub 2 minus x sub 1. That would be our b. And we would square that. And that is how we derive the distance formula. Well, notice here I've got y1 first and y2, and here I've got x2 first and then x1. And the bottom line is it doesn't matter which order these come in, because if I have two numbers, I subtract them this way. Let's say maybe I get a number 4. If I switched them, I'd had negative 4. Both numbers squared would equal the same thing. So the order here does not matter. In your book, they are going to write the distance formula as d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 quantity squared. And I'm just telling you both of these equations are the same. It doesn't matter if you do the x's first or the y's first. Doesn't matter if it's y1 or y2 in this instance. In so many equations, the order does matter, but in the distance formula, it does not matter. All right, let's do a couple of examples. In your book, we want to know what is the distance between these 2 points. Here's a point that's represented by 6, 3. Here's another point that is at the location of 5, 7. So what is their distance apart? So we can just plop this right in here. So if we called this x1, x2, we would go 6 minus 5 quantity squared. It's a plus. Remember, it's a plus because it's derived from a squared plus b squared. I'm showing you all this to help you kind of remember this formula. Hopefully it's helping. Now the second part is the difference of the y's. So this would be our y1, here'd be our y2, and again, it doesn't matter if you go 3 minus 7 or 7 minus 3. It does not matter. So 6 minus 5 is 1. 1 squared is 1. 3 minus 7 is negative 4. But let's make sure that we're clear about this. It's a negative 4 quantity squared. And a negative 4 times negative 4 is always positive. So these numbers, whatever they are, once you square them, they will always be positive. Always, 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 always. So under your radical, you will only have positive numbers when you get to this step. And then we have 1 plus 16, which is 17. If we wanted this to be exact, we would say the distance between, those two numbers would be the square root of 17. That's your distance. If you wanted to approximate that, I hope you know that that would just be over what whole number? Just over 4. 4 and a scooch. All right, when it gets a little confusing is when you have some negative numbers as coordinates. So let's do one of those. The distance between these 2 points, and if you would like to write these, the coordinates in x1, y1, x2, y2, the distance between 2 points is the square root of the difference of your x coordinates, so 11 minus 7 quantity squared, plus the difference of your y coordinates, so it would be negative 2 minus a negative 5. Do you see how that sign changed there? The first one did not, because it's one subtract the other. Okay, 11 minus 7 is 4. 4 squared is 16. So the distance is going to equal the square root of 16 plus negative 2 and 5 is 3. 3 squared is 9. Here we have the distance is equal to the square root of 25, which is equal to 5. We can simplify that. And if you would like to, I would suggest maybe flipping these numbers around and seeing that you still would get the same answer. Okay, switching gears. Now let's talk about the midpoint of this segment. So just to derive it a little bit, hopefully, we want to find out where is the midpoint of this segment. Well, I'm going to venture to say this. If I found the midpoint of A, and if I found the midpoint of B, and I extended kind of both of those lines where they hit, does that kind of sort of look like the midpoint of XY? And exactly, or the midpoint of P1, P2? This is the midpoint. I'm going to call this M. Well, how do you find the midpoint of something? It's actually the average, the halfway mark. So the midpoint of P1, P2 is your x coordinate of the midpoint is the average of your two x coordinates. You average two numbers by adding them together and dividing by 2. And the y coordinate of the midpoint would be the average of the y coordinates. Add those two together and divide by 2. That's your midpoint formula. The midpoint formula and the distance formula are always taught together in every math book, and it's kind of sorrowful because they're enough alike but different too that I think they kind of are confusing to students. They're completely separate things, right? Here the order does not matter. Here the order does matter, just that your x's come first. Now it doesn't matter if it's x1 or x2 comes first because you're adding. But the x's have to come first and the y's have to come second. All right, and why are you adding here? Here you're subtracting. You're trying to find the difference. Here you're adding because you're finding the average. All right, so let's do an example. Let's find the midpoint of the line segment AB if A is represented by the coordinates -7, 1, and B is represented by the coordinates 5, 11. So the midpoint, let's use M for midpoint, and you could put AB down here. The midpoint of AB is, add your x's together, -7 plus 5 all over 2, comma, add your y's together, 1 plus 11 over 2. So this is a midpoint, a point we're finding. And then let's just do the math. So -7 plus 5 is -2, divided by 2 would be -1, and 1 plus 11 is 12 over 2. 12 divided by 2 is 6. So the midpoint of that point of this line segment, the midpoint would be -1, 6. Now in your book, you will notice in some of the homework problems are find the slope of the line. Well, you had slope in the previous chapter. And again, the order is super, super, super important. What do I mean by order? The y's must go on top. Whichever y you start with on the top, you have to start with that x coordinate pair on the bottom. All right, and the slope of the line just gives you another way to describe a line. Alrighty, hope that was clear enough. If not, do use the classroom stream to ask questions about anything. I would be happy to set up a Zoom meeting for you at any time or answer questions individually. All right, take care.